Hi everyone. In this session, we'll be looking at how to combine Neo4j technologies with OpenAI to analyze trends in the job market. So the session is structured as follows. Firstly, we'll be setting the scene and defining the challenges and opportunities presented by leveraging job posting data to explore trends in the labor market. We'll then examine how to use Neo4j to analyze the relationship between jobs and skills, the skills required to perform a job. And then finally, we'll see how to use OpenAI to query a knowledge graph and surface information. So the digitization of recruitment processes has created a vast amount of job-related data posted every day on company career website, job market portals such as Indeed, Seek, and professional networks such as LinkedIn. Job postings have been used in recent years to explore labor market dynamics and to predict the evolution of jobs and skills. This presents opportunities but also challenges, as the data is often published in different formats and with not much consistency. For instance, the same job may have different job titles in different companies. The same job title might require different skills according to the organization hiring or the geographic location. Job posts published by large organizations tend to be very verbose and have a lot of details and blurb describing the business and the skills required, but low-skilled position and jobs tend to be brief with just a short list of the responsibilities and skills required. And so in this session, we see how we can use knowledge graphs to surface insights when the information is scattered across documents like in job postings. So for this session, we'll be using a sample data set of job postings from LinkedIn related to US vacancy. The dataset is basically a collection of records collected over 2 days back in August this year and stored in different files. The files containing the information around job posting has got 27 attributes, including the skills, job description, salary, location, application URL, and employment type, such as whether the job can be performed remotely or is an in-office job, whether it's a contract role, a full-time or part-time job. The dataset also contains different information on the companies posting the job, obviously the skills required for the job, benefits, all scattered across different CSV files. And so just to get feel for the data, looking briefly, we can see the most job posts related to full-time positions and only a minor portion relates to part-time and contract roles. Job posts in the dataset mostly also refer to occupations that are full-time jobs, either in sales and marketing, and quite a larger proportion in IT as well. And consequently, the skills also reflect this type of jobs, as they mostly relate to marketing and sales roles. And looking at the distribution of the job posts across companies, we can see that there is quite a bit of a collection of job posts related to large companies, obviously big names such as Google and Amazon or 7-Elevens, but also some less known companies. And so now let's look how we can leverage Neo4j to explore the relationship between jobs and skills. So firstly, from the files where the data is collected and stored, we need to establish a data model. And the graph model for this exercise is quite simple. So as you can see here, I have just connected the job with the company posting the job posting and the skills required for the job and the benefits connected with the different roles. Before uploading the data in Neo4j, as per best practices, we need to ensure that there are unique IDs for each node created. And this will ensure that there won't be problems when loading the data and creating the relationship between nodes. The dataset for LinkedIn does not have unique IDs for some of the features used in this analysis. And so we need to create, in this case, we need to create separate files with unique IDs for those features. And then what we do, we map the fields in the CSV files to nodes to establish the relationship and properties in the graph data model designed to support the analysis. And here we can see a very brief representation on what the knowledge graph looks like. And once the data can be loaded, obviously, we can visualize the relationship and explore the graph further. And this slide presents two different views of the graph. The hierarchical on the right representation in particular is useful to better understand the relationship between skills and jobs. And indeed, we can see that a skill might refer to different jobs in different companies, and some job postings contain information on the benefits associated with an opening, and some don't. Again, job posting lack consistency. We can also see that a company might have more than one job open requiring different skills. We can then query our graph using Cypher, and this is example, I'm retrieving the jobs containing management skills. We can see that many of the jobs retrieved when searching for management skills do in fact relate to managerial positions or roles that entail the management of processes. In the following slides, we see how we can leverage OpenAI API endpoints to query the graphs using a natural language. And when leveraging LLMs to retrieve information containing text, we usually chunk and embed documents. And so here I provide an example where I visualize the fact that job posts can be split into a series of tokens. However, this approach might fail if the information is contained in multiple documents, such as in job postings. And the advantage of using knowledge graphs is that we can represent information contained in multiple documents and relationship between various entities. Leveraging LLM also allows us, in turns, to query the graph model using natural language instead of code. And we do so by embedding both the query and the information stored in the nodes in our graph. So let's let's dive deeper into the approach. As I said before, in embedding-based information retrieval, we typically embed the query as well as the document containing the answers. And embedding allows us to obtain a numerical representation of text. And we then use a similarity measure to retrieve the documents that most closely matches our query based on the embeddings. Say we want to find out what are the skills required for a product manager building AI applications, we embed the query, and then we look at the documents that more closely match our query based on a semantic similarity measure. So for instance, in this example, once we have embedded both the query and the embedding, we found that the job post one is the one that has a higher similarity score, and therefore it's most probably the document that would most likely answer our query. In more details, here we illustrate how we can use OpenAI embedding endpoint to generate text embedding representing a text embedding representation of jobs and skills and store them as node properties. This will allow us to match the job skill information with the embeddings of the user query. The graph model used for this exercise is relatively simple, but we could enrich the graph by using node properties, enable information to refine our embeddings. For instance, the location, salary, and employment type of an opening representing the property of job nodes could be used to enrich and refine our embeddings. We can then use a vector similarity search to find the relevant information given the user input. For instance, a user could be interested in finding information on jobs containing specific emerging skills, or they could be interested in exploring the skills required for specific emerging jobs. And the workflow in this case is the following. As we stated before, in order to leverage embeddings and vector similarity, we embed the user question with the same text embedding model that we use to embed the node context information. This allows us to transform text into numbers, essentially, and based on that, we can calculate similarities between the query and the textual information. We then use the consign similarity to find the most relevant nodes and return their information to the LLM. The LLM will then use that information to construct the final answer based on the provided information. And this concludes my session. It was short and sweet, but I hope I could at least give you some intuition behind how we can use OpenAI and Neo4j technologies to surface information on labor market trends and dynamics. Thank you very much.